Okay, hi all. Today we want to talk about some new terms, the angles of elevation and angles of depression. So an angle of elevation is just the angle that your eye line makes with the horizontal when you're looking upwards. And an angle of depression is just the angle that your eye line makes with the horizontal when you're looking downwards. So to give an example, if, for instance, you were standing here, this dot, we'll call it Y for you, if you were standing there, and there was a building, we'll say over here, okay, and it's standing on the same ground as you, okay, this is a building, so you're both standing on the same ground here, and you look up to the top corner of this building here, we'll call this point B, okay, if you look up there, the angle of elevation, so that's your eye line where you're looking. The angle of elevation is the angle that your eye line makes with the horizontal. So this angle in here, that's your angle of elevation. Okay, so then on the other side, let me put an arrow on that, that's your angle of elevation. On the other side here, if we had a building like this, and supposing that you were standing at the top corner of this building here and you were looking down at a point over here, we'll call it A, on the ground, same ground as the flat ground as the building is on, and you're looking down at that point. Okay, so the angle of depression is the angle that your eye line makes with the horizontal when you're looking downwards. So a horizontal where you are now is this line here, a horizontal line from where you are. So the angle that this makes with the horizontal is this angle here. This here is the angle of depression. Okay. So angle of elevation, angle of depression. Now, one thing to note, I guess, really, is that ordinarily the angle of elevation and the angle of depreciation, or depression rather, are equal. If we take an example here, if we look at, I suppose, the building again here, if you like, and we take some point over here, and we'll call that A. We'll call this top corner here B. So the angle of elevation from A looking upwards is this angle here, isn't it? And the angle of depression from B looking downwards is this angle here. Okay? Now if you imagine, right, that I drew a a vertical line straight up from A to the top. Oops, that's not straight up. Straight up from A to the top here. So it's parallel to this. So you imagine I'm forming a rectangle here. Okay, if I form that rectangle, well then a line from one corner of a rectangle to the other, this diagonal line here, it divides the rectangle into two equal sized triangles. Not only are they equal size, they're identical triangles, just one is turned a different way to the other. Now, if these are identical triangles, then that's the right angle in this triangle, this is the right angle in this triangle. We can see this small acute angle here is the same as this small acute angle here. Now, my diagonal wasn't very straight, unfortunately, so it makes my drawing poor. But this small acute angle here is equal in size to this small acute angle here. So we can see every time that the angle of elevation is going to be equal in size to the angle of depression. That's one thing. So the next thing then is, how do we use that in questions? Well, an example of a question here might be, okay, it might be, you are told that you're standing on the ground here. We'll give you a Y again. You're standing on the ground, and across from you there is this tree standing on the same ground. So we'll say this is the tree. Okay, and you want to know what the height of the tree is, given the fact that you are standing, let's say, exactly 20 meters from the middle of the tree, and you're looking for the height. And as you look at the top of the tree, you know that the angle here looking up, the angle of elevation is 45 degrees. Okay, so you want to know the height of the tree. So what they'll often do is they'll describe this as the angle of elevation for you. They'll try and make it a real life scenario. So they'll call this a tree, but really all the tree is the other side of this right angle triangle. So all you're doing really in these types of questions is you're trying to find the length or a length of one side of a right angle triangle. So if that's the height of the tree, we might call it h. You go through the same process as always, sketch your triangle as we have here, label your triangle. Well, if this is the angle we're using, then this is the opposite, this is the adjacent, and this is, if the tree is vertical, then this is your right angle here, isn't it? And so this must be your hypotenuse. Okay, so we want to find out what h is, so we must work out which one of our trigonometric ratios we're going to use. So we're going to use one that has the opposite in it and the adjacent in it. Oh, I put in add adjacent, and the only one that has opposite and adjacent is tan. So tan of 45 degrees is equal to opposite, which is h, or if you call it x, whatever you want, over the adjacent, which is 20. And then all we do is multiply across by 20. 20 tan 45 degrees is equal to the height. And if I put this into my calculator, well, I just know off the top of my head, tan 45 is 1, so 20 times 1 is 20. H is equal to 20, so if I'm to write it with the correct units, the height of the tree is 20 meters. Okay, the height of the tree is 20 meters. So that's all there is to it. One last thing, though, before we go, is another piece of terminology that you may hear in these questions that I'm about to ask you to do is something called a clinometer. Now, we have several clinometers in school that we'll use when we get back to school, so you'll see exactly how it's used and what it looks like and everything. But a clinometer is something, is an instrument that you usually, when you're standing on the ground, you hold it up to your eye and you look through it at some point higher up or lower down, in this case higher up, and it allows you to measure the angle of elevation. So it'll give you what this angle is here. If you're standing here and you look through it up to the point B, it'll tell you what the angle of elevation is. Or alternatively, you could be standing, we'll say, up on top of a building and looking down at a point in the ground. So looking through the clinometer, and it'll tell you what the angle of depression is. So that's all it is, a clinometer. And as I say, we'll get a chance to use them very shortly, hopefully.